across the ocean is a giant unlike any other. A 2,500-ton aircraft carrier traveling at 500 kilometers per hour with 20 aircraft ready to deploy anywhere in the world. And you guessed it, it was Soviet. In the 1960s, a brilliant mind, that of Robert Bartini, the most eccentric Soviet aerospace engineer in the world, brought to life a concept of a ground effect-based vehicle that would have changed naval warfare forever. This is the incredible story behind the ekranoplane-aircraft carrier. The genesis of the Bartini A-2500 ekranoplane carrier traces back to the 1960s, when Robert Bartini envisioned a revolutionary new mode of transportation that could harness the ground effect phenomenon. The ground effect, of course, refers to the increased lift and decreased drag experienced by an aircraft when flying close to the ground or across a water surface. It's just like riding on top of a bubble. By leveraging this principle, Bartini proposed in the early 1970s an ingenious solution to the Soviet government for both the lack of aircraft carriers and their flaw of rather slow deployment throughout the world. And these would be carriers built with ekranoplanes. Unlike the other famous Soviet engineer, Rostislav Alexeyev, who based his ground effect concept around vessels with wings, Bartini was an aerospace engineer and had a different approach. He would build a smaller ekranoplane, the VVA-14, that was designed in a way to harness the ground effect using a much larger surface area than the gigantic KM, and thus this version would fly several meters higher, allowing the pilots to operate in severe weather conditions where waves or winds wouldn't affect them. This would remove the one flaw that had plagued ekranoplane design in the past. The VVA-14 was found to be completely controllable and stable at a height of 8 meters above the water, but could fly in perfect conditions up to a staggering 12 meters above the waves. By scaling up this simple design, Bartini was certain that both the weight and purpose of the ekranoplane could be further modified and allow for some truly extraordinary concepts. Cracking to work, he came up with the first ekranoplane carrier concept called the A-2000, and there was even a scale model built for testing. But Bartini didn't stop there, and he proposed an even larger and heavier one for actual use. This one would be called the A-2500 ekranoplane, and it was designed to be an awe-inspiring behemoth, measuring approximately 180 meters in length and boasting a wingspan of over 120 meters. Its sheer size dwarfed some of the traditional naval vessels of its time, so you know Bartini was seriously changing the game. It would be powered by 10 jet engines that were mounted atop of its fuselage. It would be able to go up to 600 kilometers per hour, which is around 373 miles per hour, while cruising up to 20 meters above the water's surface. This cruising altitude would eliminate the restrictions of flight due to severe weather conditions and waves, and would allow the aircraft carrier to operate in oceans without limitations, meaning it had all of the advantages of a carrier without the restrictions of an ekranoplane. The 6 engines in front would only be used for takeoff from the water to create a cushion of air which the A-2500 would sit on top of during flight, while the 4 aft engines on the vertical stabilizers would actually push the aircraft forward. The fuselage was organized with several hangar decks around a central elevator that would house up to 20 fighters and other multi-role jets, along with several naval AWACS aircraft, which the Soviets were developing as well in the 1970s. Future video, anyone? Due to the high cruising speed of the aircraft itself, it would actually match the takeoff speed of the jets like the MiG-29 or the Su-27. So there would be no need for a specialized VTOL aircraft or catapult system. They would simply lift off the deck on full afterburner, having a starting speed of 300 kilometers per hour and quickly be deployed into action. That means a more safe, air quotes, launching capability than a regular aircraft carrier, with the jets already at their combat speed without any effort. The crew of this gigantic carrier was to be around 400 personnel, with 250 being the flight crew, whose quarters were on either side of the craft below the hangar level. In the forward section, or nose of this aircraft, is where the bridge and the cockpit were located, and on top of both the vertical stabilizers, approach control and main communications quarters would navigate the approaching fighters during the landing phase. So pretty much two control towers. Landing would be kind of tricky though, because the aircraft would have to match the speed of the ekranoplane, and then some kind of locking mechanism or docking up would have to capture the aircraft before it turned the engines off, or it would blow away in the wind. Likely this would look something like air-to-air refueling, but with extra steps, and 10 times more difficult. And there was no room for error or second approach. It sounds like fun. However, this unique combination of size, speed, and capability endowed the ekranoplane carrier with unparalleled strategic potential, and this is exactly what the Soviets got excited about. One of the big differences between this type of ekranoplane and the Caspian Sea Monster was its ability to fly over ocean waves, negating one of the severe drawbacks of the previous machine. This was all thanks to special engineering, aerodynamic design, and the engines. The Bartini A-2500 ekranoplane was conceptualized to serve as a high-speed aircraft carrier capable of launching and recovering fighter jets and other aircraft. Its ability to traverse vast distances at incredible speeds made it an attractive asset for the military planners, particularly during the height of the Cold War. The Soviet Union envisioned that the A-2500 would be a potent weapon for projecting power across oceans, bypassing traditional naval defenses and striking targets with unprecedented swiftness. And it would balance out the power dynamic between the Soviets and the United States when it came to naval power. Moreover, the ekranoplane's low-altitude flight profile afforded it a degree of stealth, making it less susceptible to detection by radar systems compared to conventional aircraft flying at higher altitudes. This stealth capability further enhanced its appeal as a platform for conducting covert operations and surprise attacks. Sounds pretty fantastic, right? So why didn't they build it? Despite its groundbreaking design and potential strategic advantages, the Bartini A-2500 ekranoplane faced numerous challenges and limitations. One of the most significant obstacles was the sheer size and complexity of the platform, which presented logistical challenges in terms of construction, maintenance, and deployment. Its massive dimensions required specialized infrastructure for docking, refueling, and servicing. It limited the number of suitable operating locations to seas or nearby Soviet ports, and furthermore, the advanced technology and materials required for its construction were expensive and difficult to procure, especially with the constraints of the Soviet economy in the 1970s. Plus, we have to talk about the 1970s in terms of technology. Even with today's technology, this type of ambitious design may not even be feasible. And even if it was built, the vulnerability of such a large, expensive platform was a huge problem. None of the conventional ships could keep up with this vessel and protect it, and it would have to rely on aircraft during wartime to be its escorts. And while this plan might work to some extent against enemy aircraft, or if it was deployed near the Soviet coastline so it could retreat into a safe harbor, if it went to war and had to operate off the coast of the United States, there was no real defense against an anti-ship or even anti-aircraft missiles. The giants like ballistic missiles, submarines, or aircraft carriers are powered by a nuclear reactor, and for a good reason. A nuclear reactor can provide power for a long period of time without the need to refuel or even stop at all. Which, in the case of the Cold War, when vessels need to go almost forever, this is very important. Fragile aircraft carriers that need to dock every few days to refuel are easy targets, and the logistics behind them are pretty much impossible. Of course, there is the nuclear option as well, with both the Soviets and the Americans playing around with the idea of a nuclear-powered aircraft, but soon found out how impractical a flying Chernobyl is. However, the main issue with a nuclear-powered aircraft, especially in the case with the ekranoplane carrier, was always the weight of its protective shielding needed for the reactor itself. But the weight wasn't really an issue with these mega ekranoplanes because of the ground effect. So maybe nuclear power would have solved a lot of its problems. But it wasn't bureaucracy, technology, or the changing face of the Cold War that ended this project. It was that, unfortunately, Bartini himself passed away in 1974. And as the Soviet Union lost probably its most eccentric aerospace engineer and aircraft designer, his dreams of the ekranoplane giants followed with him. So thanks very much for watching.